We have two functions. F of x is this equation and g of x is this graph. And for each input-output pair, you're going to determine whether it satisfies function f, function g, and it could be both or neither as well. So inputs, what letter do we usually use for inputs? And notice that in our function notation, they have the input in parentheses. So like when it's an equation, you're going to plug into that equation. I'm going to write it off to the side so that way I don't have to scroll as much. And also let me get my pen going. Hold on. Sorry, it's not loading, so hold on. Okay. Okay. So and then I'll try to like leave it so that I could see the graph still, but still be able to answer the questions. So we're seeing if 0, 3, 1, 6, and 2, 10, so these are all input-output pairs, X's and Y's, if they satisfy either or both or whatever. So from the graph, you'd be seeing if it satisfies it if it's on the line. So like 0, 3 touches the line. So you would say yes for g of x. We still need to check f of x, but g of x is satisfied by this one. 1, 6 would be here. So is it satisfied by g of x? So don't pick that for 1, 6. And then 2, 10. Is that satisfied by g of x? Now, f of x, I have to plug in, like I have to do the calculations, and you can use a calculator for that. So for the first one, I need to plug in a 0. And even though you probably know like a lot of the rules, like anything to the 0 power equals what? Actually 1. So that's why, even though you might think you know some of the rules, just use a calculator. But it will be 3, so it does satisfy f of x as well. Does that make sense? When I plug in 0, I get 3. So it does satisfy that one. Plus, this is in the y-intercept spot, right? And this would be a y-intercept. So this first drop down will say both because it satisfies both. And then you're doing the same but with the others. And I'd split my screen and show you the calculations if I need to, but I'm just gonna do them on my handheld calculator. Sorry, I'm messing up my given equation. So anywhere that there's an x is what I'm plugging the 1 in. And then it's 3 times 2 to the power of 1, which ends up being 6. So we get f of 1 equals 6. Does it satisfy function f then? Is this input output pair valid by function f? So then make sure for that one you put just f of x for that drop down because we know it didn't satisfy the g function. And then the last one to test out would be plugging in 2 to this function. And friendly reminder, anytime you plug in, you should use parentheses, but if you don't, it won't really make a difference here. 3 times 2 to the power of 2 gives me 12 in my calculator. I did that. So is it satisfied by function f, 210? So then just g of x for that one. So then when I scroll down, I'm only going to put function g for that one. All right, so questions on that one? Questions on others? Number 4. Okay. So we have which number pattern is a function that can be described by an exponential equation with the common factor of 4. And they're telling you there's 3 answers that are correct. So exponential functions have what general setup? Okay, good. And if we are saying that our common factor is 4, what letter is for the common factor? B. And factors are things that we multiply. So if it wants a common factor of 4, because they have it in a lot of different representations here, if the common factor is 4, then it needs to be multiplying by 4 to get to the next number. So what's negative 5 times 4? Is it negative 1? Then don't pick that one. It looks like in this one, they're adding 4 each time, which is not the same as having a factor of 4. Okay, so don't pick that one. What is 0 times 4? Is it going to be 4? So then don't pick that one. That one is also adding 4 each time. Not a factor of 4. What's 1 times 4? Is it 4? It is. And then 4 times 4, is it 16? 16 times 4, is it 64? 64 times 4, is it 256? So that is a pattern that has a common factor of 4. I'm multiplying by 4 to get to the next number. The next one is 20 times 4, 5. So then don't take that one. That was trying to confuse you and giving you like dividing by 4. Yeah, we've talked about like how if it's multiplying or it looks like it's dividing, it's an exponential function. So this is an exponential function, but the common factor would be 4 if the numbers are getting smaller. Okay, so it has to be what you're multiplying by each time. What about 0.05 times 4? Is it 0.2? 0.2 times 4, is it 0.8? 0.8 times 4, is it 3.2? And if I times 4 again, is it 12.8? So then there's another one, which is the third one. And of the ones that are left, it looks like there's equations. So let me erase what I crossed out already. And they're all equations, and they should look like our exponential function setup. They're kind of using a little bit of weird notation, like instead of doing f of n, they're doing like a sub n. It's still like function notation in a way. But remember, key thing is common factor of 4. Then you'd be multiplying by 4. Does this first one on my screen look like they're multiplying by 4? All right, 1/4 is not the same as 4, right? So no, don't do that. In the second one on my screen of the equations, are they multiplying by 4? Okay, and they're also like, it doesn't really look like this either, but they're adding 4, so no. Over here, are they multiplying by 4? And we also see that our common factor is what's attached to the exponent, and this is the variable, the exponent. So we're gonna select that one, and then just for making sure, is this one multiplying by 4? When it's n to the 4th power. All right, that's not the same thing, right? Multiplying by 4 and having something with a power of 4 is not the same thing. So those 3 answers would all have an exponential pattern with a common factor of 4. Good questions, comments, concerns on that one. All right, questions on others? Okay, good. That one has a lot of calculations involved, but you should be using a calculator for it. So the only hard part is knowing what exactly to calculate. You have, and it says it gives you a graph, but really it gives you the equation, which you could graph, but I don't think that would necessarily help you in this. You have that given equation. The coordinates of A are 2C and the coordinates of B are 6D. Find the average rate of change between points A and B, round the answer to the nearest hundredth. So it's an average rate of change problem. When you hear that phrase, average rate of change, what formula should your mind automatically go to? So that's linear. What did we say over here?
Oh, and um,
Okay, good. So she's saying M because it's the same as our slope formula, but really it's our average rate of change formula too. Because I mean, slope is just for linear functions. Average rate of change is for any function, but they just have to tell you where to look. And they're telling us we want to find the average rate of change between these points. For this formula, we need to have two coordinates. That's why we use x1, y1 and x2, y2. And we kind of have it, but it's missing some parts. So we can make point A, which is 2C. I'm not going to put the C right now. And then point B, which is 60. They're giving us the x of each coordinate. We need to find the y of each coordinate by plugging the x into the x of that function notation. Okay, so before I can even do this formula, I need to plug in a 2 to f of x, this, and then I also need to plug in a 6, because that's my other x value that I need. Whatever output I get, I am going to use that as the y for that coordinate. All right, and you really have to use a calculator. There's no other way around it. I'm going to do it on my handheld calculator, but because I've shown you throughout the lessons in Desmos, if you need to see it in Desmos, make sure you ask. But when the x is 2, I get 138.24. If you're getting something different, and that's going to be the y value of this. Don't round early. Wait till the end. And then when the exponent is 6, I get a longer number. I get 11197.44. And that's going to be the y to this. So I'm trying to squeeze it in there. 11197.44. All right, so this, we're not quite finished yet. Now we need to plug it into our average rate of change formula. But any questions so far? So then in my average rate of change formula, I highly recommend like do the labeling like I did. This will be x1, y1, this will be x2, y2, and plug it in. I would put it all at once in the calculator, so I'll show you what that looks like in Desmos. But if you're using a handheld calculator, you would probably want the numerator in parentheses and the denominator in parentheses. Because otherwise it'll divide whatever numbers are in these two spots, and the dividing has to be last. We have to have already subtracted these and then divided them. So yeah. y2 minus y1, your x minus x1. But then if you use Desmos and you set this little division sign, it'll automatically put it into fraction form. Again, then don't round it to the very end. And this is our average rate of change. And it wants you to round to the 100. How many decimal spots is 100? 2. And this really only gives me to the 10th place, so that means the 100th spot has a 0 in it, so this is going to be my number. But on your test, whatever it says to round to, make sure you round to that. Because I am taking off a point or two for everything. But if everything else is right, but just your rounding was wrong, you get like an 8 out of 10 with this problem. All right, questions, comments, concerns? Other questions from study guides? Number 7. Okay, so we have a John purchased a car for 25,000. The car is expected to depreciate, which if you don't know what that means, I'm telling you now, it means a value if it's depreciating. At a rate of 15% per year. This equation gives the value of this car in dollars after T years. And it says first find V of 4. So what is that for replacing? What was in the parentheses before? A T. So in our equation, wherever I see a T, I'm going to replace with a 4. So that's our function notation we learned about last semester. And just making sure I have the right amount of zeros. And then I'm going to use my calculator to put that all in at once. So I have 25,000 times 0.85 to the power of 4. And I drop down. My drop down would be this value, which out of the options that are there, only 2 of them would possibly make sense, right? If it's depreciating or losing value, and we're talking about 4 years later, we wouldn't expect the value of it to not change. And this one could be right, it is lower, but doing the math, I got this in the calculator. So questions on that? Okay, then we have complete the following to describe what V of 4 represents. So blank years after the car was purchased, the value of the car will be blank dollars. So go back and reread it if you need to. Attach your units to the numbers. Remember that each of these can be represented as a coordinate. So like each of these could be represented by a graph. And we're comparing T years and the value of the car. If I was graphing, what would go on my x-axis? What is usually on my x-axis? The time, and this time it's in years. So, coordinates go in the order x, y. This means 4 years. Which means the other thing that we were comparing, which was the value of the car in dollars, is my y values, my outputs. So this 13,000 approximately would be like $13,000. So 4 years after the car was purchased, the value of the car will be about $13,000. So good there. All right, any other questions? From the constructive response, online to be from my Excel or any other practice. Yes. 12. So the ordered pairs shown in the table are generated by function f of x, which statements are true about f of x, like all that apply. So it doesn't tell you how many answers there are, you have to check them all. So first on my screen, it says the function can be represented by the equation f of x equals 2.5x plus 1. The way that this equation is set up, would that be linear, exponential, or neither? Linear, because it's more in the form y equals mx plus b. Because of that, well, first of all, you could also, like, if it gives you the equation, you could try plugging in these numbers and seeing if they give you, like, the output pairs. But we know that linear functions do what each time in the lines? They add or subtract each time. So let's see what the pattern is, if we can find any. If I was trying to figure out what plus 0.16 gives me 0.4, then I might subtract them and see if it's consistent throughout. So see if adding 0.24 each time is the pattern. Is 0.4 plus 0.24 1? So then that's not the pattern. So it can't be linear. Then the second one on my screen says f of x is an exponential function. Exponential functions do what each time? They multiply each time in the y values. Notice the x's are going up by 1, which is only really important to note because of I don't know, you just want to see if these numbers in this column would be next to each other in the pattern. And maybe try to find numbers that are easy to work with, like what times 1 will give me 2.5. And then see if that's the pattern. If it's really hard to even do it with any of the numbers, try taking one of the numbers and dividing it by its previous number and see if that's the same common factor. So when I try that out, I do get 0.25, or sorry, 2.5. So 0.16 times 2.5 gives me 0.4. 0.4 times 2.5, let's see what that is 1. And that's all I have in the pattern. So is this exponential if it's multiplying the same number each time? So we will pick that one. It says the function can be represented by this equation. So first of all, is that equation an exponential type equation? It is. It looks like we have 2 that could be exponential. So just make sure whatever one you're looking at, that if I were to plug in these x's, I get these as the outputs. So also keep in mind your exponential function setup. Based on this table, what would be my initial amount? No, I don't know my desk door. I said don't put it on my desk door. Okay. So that's the kind of there. So that's what I like. Sorry, what? 1 for the initial amount? Good, because initial amount is also your y-intercept. It's not just the first number they give you on the table. It's the y value and x is 1. So if I was making it from scratch, this is what it would be. My common factor, what I'm multiplying by each time is this. And what's 1 times 2.5? So this one looks like the answer anyway. But again, you could try plugging it in, like you could try doing 2.5 to the power of -2, and it does give you this output. What I worry is that maybe there will be multiple problems, like equations that could work for some of these. It has to work for all of them. If you're not sure how to set it up and you're just trying out answers, it would have to work for all of them. All right, so we eliminated this one. Then when x increases by 1, f of x increases by a factor of 2.5. You guys agree with that? Do they know? I'm gonna pick it because as the x increases by 1, we're saying that this column increases by a factor of 2.5, meaning like when it says factor of, that's what we're multiplying by. If you're confusing it with like the other percent problems we talked about, that would be like it's losing 2.5% is when you use that other setup. For this one, when it says increases by a factor of, that means we're multiplying. Right? Lastly, is the y-intercept 0, 0? All right, no, we said it was 0, 1. So just these three. And yeah, that's right. Just those three. And don't just blindly copy, make sure you're thinking the correct ones, like probably shuffled on your screen. And I think that's all we have time for. So if you have other questions, make sure you ask, email, say number 8 from the practice, like that. Odds are another class will ask about it, but if they don't, I can probably answer it during